We'll learn how to evaluate triple integral 1 upon x square plus y square plus z square the whole raised to 3 by 2 dx dy dz over the region bounded by the sphere x square plus y square plus z square equal to 4 square and x square plus y square plus z square equal to 7 square. Sphere equations are x square plus y square plus z square equal to 4 square and x square plus y square plus z square equal to 7 square. Since the given equations are sphere, we'll prefer using spherical polar coordinates. Spherical polar coordinates are very much similar to polar coordinates of a circle. Polar coordinates of a circle is x equal to r cos theta. For a sphere, it becomes x equal to r cos theta sin phi. Similarly, polar coordinates of a circle is y equal to r sin theta. For a sphere, it becomes y equal to r sin theta sin phi. The extra element is sin phi. And the z over here is r cos phi. There is no z for polar coordinates of a circle. Dx, dy, dz here gets replaced with r square sin phi dr d theta d phi. Remember, we'll stick to the order dr, d theta and d phi, where r square sin phi is a Jacobian. We'll move ahead with the integrand. The given integrand is 1 upon x square plus y square plus z square the whole raised to 3 by 2. We'll replace our x square with r square cos square theta sin phi and y square with r square sin square theta sin square phi and the z square with r square cos square phi. We'll remove r square sin square phi common. Check out. So in a bracket, we are left out with cos square theta plus sin square theta. Remember, there is an r square cos square phi remaining. 1 upon r square sin square phi. Cos square plus sin square gives us 1. R square cos square phi. Remove r square common. We'll get 1 upon r square in a bracket sin square phi plus cos square phi. Sin square plus cos square gives us 1. So we are left out with 1 upon r square. Check out, we have missed out that 3 by 2 which is there in the power. So we will accordingly put 3 by 2 for each and every term. So at the end we'll get 3 by 2 and that 2 and 2 gets cancelled. So we are left out with 1 upon r cube. So my given integrand turns out to be 1 upon r cube. Now we'll talk about the limits. You will be following the order dr, d theta, d phi means r is in the inner integral, theta is the middle integral and phi is the outer integral. Limit of r, limit of theta, limit of phi. Since it's a sphere, we'll draw a 3-dimension xyz plane, and I'm not that good in the diagram, so accordingly we'll manage. So this is a sphere of radius 7 and the inner one gives me a sphere of radius 4. It's the equator which we are drawing right now. We'll give the radius. Now it's a radius 4. This one is of radius 7, the bigger sphere. Now since it is bounded by the sphere, so it means I am interested basically in between the two spheres. And what's the moment of my r? R starts from origin till the outer circumference. Since it is bounded by the spheres, we are having two concentric spheres of radius 4 and 7. So I'm interested in between the two spheres. Since it is between the two spheres, from 0 to 4, the value of my r won't be considered. R starts from origin, goes up till the outer circumference. So the limits of my r will be from 4 to 7 instead of 0 to 7. Theta is equator, so it becomes 0 to 2 pi. Phi basically talks about the height, that is z. So the angle made with positive z axis. So the angle made with positive z axis will be 0 to pi. Now we'll try to integrate. Now the integration becomes triple integral r ka limit for the inner integral, which is 4 to 7. Theta is from 0 to 2 pi. Phi is from 0 to pi. The integrand 1 upon r cube. Dx dy dz becomes r square sine phi dr d theta d phi. R square sine phi, remember it's a Jacobian. Since all the integrals, check out, since all the limits of my integrals are constant, so it can be written as a product of single integral. So it becomes phi from 0 to pi, and there's one term of phi which is sine phi in my integrand, so I'll include it here. The middle integral is 0 to 2 pi, that is for theta. Since there is no term of theta, I'll just write down d theta. The next is r equal to 4 to 7. R cube, r square gets cancelled. 1 upon r dr. Now integration of sine phi is minus cos phi within the limit 0 to pi. 1 ka integration is theta, 0 to 2 pi. 1 upon r is log r, which is from 4 to 7. This becomes minus cos pi plus cos 0, minus and minus, upper limit minus lower limit. Minus and minus becomes a plus. Becomes 2 pi minus 0. This becomes log 7 minus log 4 equal to cos pi is minus 1, minus and minus becomes a plus, cos 0 is 1, 1 plus 1 gives me a 2. 2 pi log a minus log b is log a upon b, gives me 4 pi log 7 by 4. Thank you.